It's matching. Grade it. You guys are doing this with a color pen, yeah? Number 10. Woo-hoo-hoo-hoo. They did 7 different graphs.
I did all in one graph with one color.
You didn't. Oh my goodness, you're that person. Ouch. Killing me, Smalls. Sandlot, great movie. You should watch it. Okay.
Yes, it is.
It's a bell.
What is it?
Not a parabola.
It's the one that was defined by the points that were given. Kind of like, remember at the end of yesterday?
I didn't look at that.
Remember? It was defined by the points? I mean, that's pre-cal. We were doing this in pre-cal today. But you guys did that 100 at the end of yesterday, didn't you?
Oh, I did number 9.
You did number 9?
Yeah.
Well, Sophia, the nice thing is you could grade number 9, right? So then see if you did it right or wrong. There you go. So, did you guys at least get, now, those of you that did it all in pencil and didn't really label it, I have no idea how you're going to grade this. But the rest of you, if you either spread it out amongst 7 different graphs or like you doubled up a couple, etc., hopefully you'll see if you actually went 5 units to the right and didn't change anything else. Or if you reflected in the x-axis, vertical flip and shifted up 3. Ooh, the order mattered. The order mattered. Or if you had a vertical shrink. Or if you reflected in the x-axis, aka another vertical flip, and then went 1 to the left. Order mattered. Or if you did a horizontal flip, or if you shifted down 10, and there's one more, yeah? Isn't there a G?
Yeah.
Okay, we'll go there in a second. Did you guys notice in the Google Classroom, I posted a link to a web page that talked about the order of transformations?
Yeah.
Okay. It was something that you could have checked out, but you only needed to, sometimes, you only needed to if there was more than one transformation to know what order to go in. And even then, it sometimes didn't matter. Even then, it sometimes didn't matter. Ah! Did you guys stretch it instead of shrink it? Horizontal is weird. It's other than what you expect. You see 1/3 and say, yay, all the x's times 1/3. No, all the x's times 3/1. Remember, we think they're reciprocal. We think they're reciprocal. Then it would be a shrink. So I think there was one like that earlier, right? There was something on the outside? Or was it? Oh, there we go. Letter C.
Oh, yeah.
So the 1/3 was a shrink, so all the y's, literally, it's as we expect, but remember, horizontal is weird. So instead of multiplying by 1/3, we multiply by. And I showed that in notes when we were doing that dilation page. Because I think, what did I show yesterday? Oh. Yeah, you take whatever's there and you flip it. You have to do the reciprocal. Then stuff hopefully got a little more normal. This stuff is a little more normal. Do you guys realize you were looking for the parent, right? And then saying what happened with the kid? Horizontal shrink. Horizontal shrink because you have, ooh, reciprocal, right? So the times 3 is like a 1/3 horizontal shrink and then a vertical shift up 1. Do you guys notice they're starting on the inside and working their way out with the transformation order? And then you should have gotten your graph. Wait, how did you guys get your graphs? That's a good question. Did you plug in like x is 1, x is 2, x is 3 and just plot it?
No, I just
I was thinking, and maybe this is what you were doing, Izzy, I'm not sure. Couldn't you take the square root of x function that we talked about yesterday and do like 0, 0, 1, 1, 1, 2, 3, 4, 2? Couldn't you get a few points? And then, like with number 10, couldn't you just change the few points?
Yes.
You see what I'm talking about? So then couldn't we horizontal shrink? We're multiplying the x's by 1/3. And then we're doing the y's plus 1, right? Okay, so couldn't we, in theory, couldn't we have multiplied, well that one's just 0, 0, so the x times 1/3 doesn't change anything, and then up 1. Got him. And then this guy, that's the point 1, 1. Couldn't I change him to x's times 1/3 and y plus 1? So wouldn't that be 1/3 and then right there? So that'd be the point, what do we have? We have 0, 1, then we have 1/3, 2. And then we have the point 4, 2. Do you guys see where I got these special points? I know the square root of 1, I know the square root of 4. And then I could have cut that in 1/3, which would be 1 1/3. He would be there. And then plus 1. So wouldn't that be 4/3 and then 3? You guys see it? So the parent function, maybe it's not just helpful for the parent function to know it starts there and it swoops, but to also have a few what we would call representative points. And if you have a few representative points for every parent, then you can say, wait, what's happening to the kid? Oh, got it. And then you can take the parent points and be like, sweet, transformations just like you did in number 10. You guys see what I'm saying? So the parent functions, you don't just have to have memorized like the general idea, but have a few points down, because then we can make whatever transformations we need. So it ended up being shrunk, and as it's shrunk in all actuality, it's also stretched, right? Because it kind of just, the y's move upward also. But did you guys figure out what this letter D was talking about, the function notation? Okay, because you have to think about your parent, right? And then come to the equation and say, okay, so what if I took out the parent and I just put in f of x instead? If I took out the square root of x and put in, no, I can't just put f of x plus 1, because wouldn't that just be square root of x? What did I need inside the square root? So it's f of 3x plus 1. So what I'm doing is I'm taking the original, I'm saying, okay, how can I compare that to the function notation, kind of like up here, we had no idea if it was a square root. Well, it's not a square root, but without the graph, I don't know, it's just some random function. They wanted the function notation of the transformations. And if you were able to rewrite it like this, for sure you should have known, hey, that's horizontal by 1/3, hey, that's a vertical up 1. So some people get really confused when they see square roots or ln's or e's. But if they can think about it in general terms, then all they have to do is remember the parent and then bring it all together. Is that kind of okay?
Why did you drop
Oh, it's because of the directions. Who has the directions for letter D? What would they ask you? Function notation says instead of actually showing the radical, use f of x, use his name instead. So you're taking this, taking out the radical, and using this. Is that okay? Not so sure. Give me a thumbs up if you're like, I'm still hanging in there. The rest of you guys? Any comments? No. Okay, I give up. I don't know what's going on. That's number 50, right? I think so. I can't scroll up. There we go. Vertical stretch by a factor of 8 should look like that. Reflection in the x-axis is a vertical flip, so a negative on the outside. And a vertical shrink should have a negative 1/4. Number 70 was one of those, our favorite, word problems. No? Wasn't that scary? Weren't you just talking about transformations and plugging and chugging and throwing into your calculator? We did a calculator handbook. Aren't we better at it by now? No? You guys got the vertical shift, yeah? You got the horizontal shift, yeah? And you got the vertical flip, aka reflection in the what axis? X-axis with a vertical dilation or shrink because it's less than 1, yeah? I mean, that's just words. That's just throwing in your calculator and the y equals. Average rate of change. Ooh. Did anybody struggle on that one?
Yes.
Well, what's the cool thing your calculator could have done? Come on, I showed you just this trick, right? Can't your calculator do function notation really snazzily? I'm pulling it up real fast, guys. I'm not going to type in the whole equation because I'm way too lazy and it was your homework. But if I go to the home screen, how could I, all clear, how could I write this and have it do it for me? What would I have had to put in y equals? My function, right? So I would throw, no, not that one, but I would throw that whole function in and I'd be like, yay, y equals. And then can't I, you guys remember that cool shortcut menu? Alpha y equals. You can make a nice pretty fraction. That's cool. And up top you can do, where do I find the y1s again? Trace? Couldn't I do y1 of 10? Minus y1, I know, I'm teaching you how to be lazy. y1 of, what was it, 3? All over 10 minus 3? It would have been as easy as that. Because wouldn't that have taken your function in your y equals, plugged in 10, plugged in 3, and then solved it? Dun, 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 dun. Now, people with the yellow button, remember, the way to get to those y vars, you have to go to vars, y vars function. You can get there too, it's just longer. And if you can't make the snazzy fraction, couldn't you also do this another way? Oh, do you guys know you can hit the second button and right or left and go to the very end or the very beginning without having to scroll all the way through? That's super snazzy. It's not going to work because I have nothing in there. But you would have, or you could have also done it with, careful, parentheses in doing that whole y1 of 10 minus, oh, my 10 didn't show up, sorry. If you don't have the nice spiffy fraction or you don't know where to find it, that's okay, you don't need it. You just need to close in your numerator and close in your denominator, right guys? Remember? But careful, not just the numerator, you also have to do the denominator also. Now, I know you guys can do 10 minus 3 is 7, I know, but just proving a point. Close in the numerator, close in the denominator. It's not going to work, I have nothing in there, I realize that, but that's how you would have done it. Are we okay? Okay, I just want to make sure you can use your calculator, because that did not have to be hard. Plug and chug, and then I think it's measured in thousands? No, millions?
Millions.
Millions. So we had to move that decimal place 6 places, which is why it ended up being 976,000. Then you decide to plug in 18. Oh my goodness, we just reviewed how easy it is to plug in with our calculator, and then just explain what that is. Oh yeah, those are millions of households. Dun, 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 dun. Homework questions, what do we got? You guys were talking like it was crazy hard. It wasn't that bad after all? What was the worst one? Yeah, I agree. Which is why we spent some time on it yesterday. If you guys have any other questions, come find me. But for right now, what on earth is going on with section 1.8? Combinations of functions. Combinations of functions. Anybody figure out what the blanks are for?
No.
No? You're welcome. Sums, differences, products, quotients. How to put functions together with addition, subtraction, multiplication, and division. Yeah? Now, to be honest, most of you should be looking at this side and being like, oh, no big deal, I can do that. You give me F, you give me G, and I'll put a plus, I'll put a minus, I'll put a times, I'll put a divide. But can I show you where it gets tricky? No? You sure? I'll just do it homework and get stuck and get it wrong. Already.
No.
Didn't work well for some of your quests with the difference quotient. Some of you with the difference quotient. I told you, I warned you, you were supposed to highlight and write with a colored pen. That when you see something like difference quotient, quest corrections up here. F of, what did you guys have? 7 plus H? 8 plus H? 7 plus H. When you were supposed to do that, I had some of you guys take your F, which was, at least one version, was it 5x minus x squared? Yeah. Something like that? Some of you guys looked at this and said, oh, F times, yay. And I know why you did it. I warned you about it. This was wrong. Why? What are they doing that's mathematically something they've learned before that's just wrong in this context? What are they doing?
Scotch tape.
Oh, they have to factor.
Yeah, they have to.
No.
Oh, I got it right now.
What are they doing? What's the mistake? No, but what's the mistake?
They're
They're needing to distribute. They're seeing this not as f of, they're seeing it as f times, right? Do you see how they did f times instead of f of, right? They said, who's f? Okay, put him. Times. Let's go. But that was wrong because function notation isn't f times, it's f of. So how were you supposed to solve this? Look at each of these x's as little input boxes and say, if I ask for f of 7, plug in 7, plug in 7, plug in 7. If I ask for f of 7 plus h, plug in 7 plus h, plug in 7 plus h, plug in 7 plus h. That's the right way, right? Or was the notation tricky? Yeah, for a lot of people. It can totally be tricky. So, let's make sure this notation isn't tricky. Ready? What do you think is the common mistake if you see this in homework or on a test? What's the common mistake? This is what it really means. What's the common mistake?
I think it means multiplication.
Yeah, let's add f and g and then times x. Wrong.
Right.
Let's subtract f and g, well, g from f, and then times x. Wrong. Right? This isn't times x. What is it?
Of x.
Of x. So the worst part is the notation. The worst part is the new notation. Well, it's the new notation and what to do when you have two weird things added together or subtracted or multiplied and it looks weird. There are two places to watch out, but the first one is the notation. It's really not that hard. It's f of x plus g of x, not times, not times, not times, not times. Write it down, not times, if that's something, it sounds like nap times. Oh, I like that. Kind of. Not times. Good? So if we have that, good question. What's this asking for? If it wants f plus g of x. When I say of, what do I want you to think? Not times. Plug it in, not times. They want this one, and they want this one. F plus g of 3. Not what?
Not times.
Not times. Okay, what am I doing?
Hold on. You're
Yeah, plugging in. I'm doing f of x, right? Plus. Are we good?
and you're putting in 3 for the x.
Should I stop?
No.
But I am only allowed to keep going if I can combine like terms. True?
Yeah.
Which this one you totally can, but just a warning in homework, you can't always combine. If they're not like terms, just stop. My ones cancel? Are we good?
Yes.
Okay. And how do I keep going? Times 3!
No, plug in 3.
Plug in 3. Because this is f plus g of input. So then wouldn't this be 3 squared plus 4 times 3 PEMDAS? Can you do it right? Mm-hmm. What do you get? Are we good?
Wait, so what happens with the extra?
Extra what?
So you cross out the ones. What happens with the extra?
Oh, 2x and 2x combined to be 4x and x squared. Okay.
Is that it? So you just put it down there.
Well, f plus g of x, that is the function, right? And then I had to plug in 3. So go for it. Which, guys, couldn't we technically have just done also f of 3 plus g of 3? You didn't have to plug in 3 to the simplified f plus g of x. You could have just said, hey, 3 is 6, and then 3 is 9 and 15 and 14? No, 15, sorry. And 6 and 15 is 21. So you could have done it this way, or you could have used the equation that you get. Either one, right? Either one's okay. Okay. Shoot. What if I was to give you something like this? How about you read the equation, the function, the combination you're supposed to find? What am I asking you to find? I just heard so many words right now.
Oh, that's fine.
Who is this? Okay, f over g, or f divided by g, or the quotient of f and g of x, right? Pretty simple. Find me the quotient of f and g and state the new domain. You guys got it?
Have it there.
I didn't give you that hard of a factoring one today with our cool star x. Yep.
Oh.
Because remember, notation. Did you guys figure out it's just f over g, right? Don't get tricked. It's okay. It's a good idea. Because to find domain, when you have denominators, what do you need to think? What is he not allowed to equal?
0.
So that's a factor, yeah. Can't take forever. Today's not like a learn factoring day. It's just a review day. So, of factoring. What do I do?
Multiply 3 and negative.
Mm-hmm. You get negative 12. What goes down here?
4.
Mm-hmm. What gets you there? Why am I writing it kind of awkwardly down low?
So you can actually just
Remember it?
No?
I haven't shown you guys the modified x.
No.
You multiply and
You can do your little grouping and then go from there. Or you could say, who's your leading coefficient?
That's big IQ.
These are your x terms and these are your constants. Ready? X plus 2 and 3x minus 2.
It's just small brains.
I didn't learn this until last year. I was tutoring a kid whose teacher was like, hey, because you can't reduce that. Oh, the 3 comes from the leading. So you always put, here, hold on, your modified x. You guys know this. This is a times c, right?
Yeah.
And then this is b. And then you find your, I'm just going to put question marks. You have to find your factors, right? And put your a. And then no.
We did grouping. You missed a grouping.
yeah, I was
This is the supercharged modifier.
supercharged.
Grouping, that's totally okay. If you're going to group, you would split your 4x into 6x and negative 2x, and then you would group what's in common, go. Right?
Yeah.
So if you want to do that, that's
And then would the negative 4 be by itself or with an X?
No, it'd be with
if you were
negative 2.
grouping,
Yes, sir. So it'd be 3x squared plus 6x. Yeah. Also, the 4 would not have an X.
Almost. I'm just making sure the factoring's good. Because we're supposed to find a domain, and the domain are the zeros. And factors find zeros, right? Yeah, I'm finding my domain. So either way, to get 3x minus 2 and x plus 2, why were we factoring? Because we're trying to find the zeros, because we're trying to state the domain, right?
You stop there.
No, I need the domain. Oh, my domain is, what is x not allowed to be? -2 or 2/3. Remember, if your brain doesn't jump to those answers, you're setting each one equal to 0 and solving. Is that good? Subtract the 2, add the 2, divide the 3. Grouping works. Okay, superstar x is pretty cool.
You don't take kids to
You don't have to call me.
You don't get. What?
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 I don't know.
Okay,
And you know what?
here's the last big idea. But he's the hardest one.
No. No, I'm not. I don't want to do it.
I literally stole it from the teacher who I was tutoring this kid last year. And I was like, wow. It was cool. It was West Ranch.
They're good at sports.
So ready for compositions?
No.
Better become ready. Here we go.
Oh my goodness. Oh,
Read it for me in words. How would you read this?
f of g of x. Fog.
That makes sense? Yeah. Wow, look at you guys. Maybe you are ready for this. You told me no. So what if I was to just have you focus on g of x for a second? Doesn't the x get plugged into the g?
Yes.
But where does the g of x get plugged into?
Yes.
Got him. So the x gets plugged into the g, and then the g of x gets plugged into the f. Huh. It's like the fly that gets eaten by the frog that gets eaten by, what's the predator's frog?
Lizards.
By the shark.
Wait,
By the lizard.
snake.
By the rattlesnake. Oh, here we go. Dude,
That was
myself.
being so weird.
The cheese that gets eaten by the mouse that gets eaten by the rattlesnake. There you go.
Frogs are in the ocean.
The cricket that gets eaten by the lizard that gets eaten by the
Small
rattlesnake.
brain.
Okay. Do you see?
I'm not saying that.
Yeah, I'm wondering what kind of frogs are they?
No, but there's
Shark
bull
has
sharks that
There's-
live in.
oh,
bull sharks.
I got a star.
Emily, we need Ava to tell us about this.
I got a starburst for saying bullshit in class. What?
And you laugh.
Okay, coming back.
I've never got a starburst.
Alec,
I
focus.
have.
Here we go. So the idea is x goes into g goes into f. X goes into g and g of x goes into f. Do you see the two of?
Yes.
So we have the g of x, that's the new input for the f. So the x is the input for g, the g of x is the input for f. Now, a quick word about domain. He's the trick, he's the watch out, he's the we need to check the domains of the inner first, and then the outer functions. So that's something that, you know what, if you don't get that today, that's totally fine. Domain we'll talk about probably in homework questions. But first of all, f of g of x. F of. Ah! Wait a minute, there's a notation. Don't worry, I got you. Fog. You guys might have seen this before because it might have been written as
F of.
little o. There's his confusing notation. There's his confusing notation. But just think of the little o, he's hollow. He doesn't look like a times because he's hollow. The little o, just think of. Yeah? And this is not times, not multiplication, right? This is a composition. This is of. So f of g of x. Okay, so here we go. We have our F, we have our G. Can you organize it accordingly? I dislike, to be completely honest, this notation entirely. I would much rather have F of G of X. What would this one be?
G of F of X.
Every time we say an F, put a parenthesis, and we close them. Yeah? What would the next one be?
G of F of negative 2.
Not times, not times, not times. Are we okay? Watch out for the notation. Okay, so for letter A. Oh, let's color code. Well, that one be blue, well, this one be red. This one. Okay. So what am I doing for A? Before, the shark can eat the frog had to eat the fly. If the fly's going to be in the frog, that's in the shark. True? Okay. So before we even talk about the shark, what do we have to do first? G of X. Where's G of X going to go? F has an input, right? What's getting put into F? G. Who is G? 4 minus X squared. So my F of G of X is going to be F. Pause. Do you guys see F?
Yes.
And what needs to go inside of?
4 minus X.
You can do it in 2 steps if you want. G, of course. And then who is G? Well, 4 minus X.
Bruh.
You see it? Who is F? Well, it's input plus 2. Well, what's supposed to be going into F? G is. Okay, fine, then put it in. But who is G? 4 minus X squared. Well, then put it in. So, if you want to think about F as a mathematical sentence, isn't F just a quantity plus 2? But as soon as we have F of G of X, it's what quantity plus 2? Well, G's quantity plus 2. Well, who is G? Well, then you go. And all we have to do to finish this problem is just simplify. So distribute your understood 1. If you can simplify, do it. But that's F of G of X. What else do we need to do?
C.
How about G of F of X? What's changing this time? Who's the bigger guy? The F or the G? This time G is eating F. Who's eating X? So then to solve him, I'm looking at this a completely different way. Who's getting plugged into this time? So I need to plug into G's input. So who is G? Well, G is 4 minus input squared. Well, what's being put into? Wait, what's being put into G?
X plus 2.
If we're doing it in steps, it'd be G of F of X. So wouldn't he be the guy that'd be putting being input to the function? And who is F? What some of you guys have already said.
X plus 2.
So the X is being put into the F, and the G is eating all of the F, and it's going in between the input spot. Now, this one's a little bit harder, because to simplify, aren't I going to have to FOIL?
Yes.
In a way that I'm not killing a puppy? To where I have my entire trinomial after FOILing it?
I killed the puppy.
And then I need to distribute my negative, don't kill a seal. 4 minus x squared minus 4x minus 4. Oops. That's awkward, the directions are different, sorry. So I end up with, you can do it different ways. Can I just write it the way it is? If you want to factor, that's fine, but there he is. Right? What would be the last step if we had time to do the last step? Plug in -2. I'm going to go ahead and do that as you guys leave. If you want to check out me plugging in -2, you can find it on the video at the end. Bye, guys. Thanks for visiting, all my visitors. Glad to have you. Hope you enjoyed lunch. HPrecalc kids, be friendly.
Especially Emily.
Get out of here. I'll see you guys later. Homework due tomorrow.
Don't be that antisocial self, dear.
People antisocial. You're welcome. Bye, guys. Welcome, welcome. Happy. Yeah.
My chair is terrible.
Because they were working so hard.
There's no reason for me to want to be here.
It's kind of messed up.
Probably
What
works
the
like
heck?
that sound.
It's a little messed up. It's so myself.
You guys remember when you were learning composition?
See the one that was work? Yes, it is.
Yeah, I thought that was gonna be a whole lot.
I got you for a long time.
So, did you say it was okay for us to miss the whole period, or just like, or like?